From Photonics Media, this is All Things Photonics, a podcast shedding light on industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, our hosts speak with luminaries, rising stars, and market leaders about the trends shaping the current and future landscape of photonics. From space and deep-sea exploration to precision timekeeping and advanced manufacturing, this is the podcast for progress on All Things Photonics. This season of All Things Photonics is brought to you by PolyScience and Thor Labs.
Today's episode is brought to you by PolyScience. For over 60 years, the PolyScience line of award-winning temperature control equipment has been helping the photonics industry reach its goals safely and efficiently. Our products are made in America and delivered globally. Please visit polyscience.com to learn how we can help you. Changing the world of chillers is more than a tagline. It's a part of our history. Today's episode is also brought to you by Thor Labs. Thor Labs believes in the positive impact of photonics and hopes today's discussion inspires you. We're a vertically integrated photonics designer and manufacturer dedicated to making your ideas successful. To join our team or to learn more about our stocked offering or custom solutions, visit thorlabs.com.
Last fall, the time was ripe for an in-depth examination of what recently imposed export control measures on gallium and germanium would mean for the optics supply chain. Both materials are needed to make alloys and compounds that are essential to the manufacture of semiconductor chips, optics, laser diodes, and other common components. China's directives mandated that its domestic exporters of these metals must now obtain a license to distribute them across international borders. The mandates raised both intrigue and concern. Photonics Spectre's coverage benefited from frequent dialogue with Sam Rubin, CEO of optics company LightPath Technologies. LightPath is a leading developer of black diamond, or BD, chalcogenide glasses, which can flourish as substitutions for germanium glass in a host of infrared and other applications. But one-for-one material swaps are complicated, and not just because of the distinctions that one material holds over another. Necessary qualifications, approvals, and even the familiar theme of moving away from what's common are all factors that are in play for such a conversation. Today, we welcome Sam Rubin to the podcast to discuss these considerations and many more. LightPath, earlier this fall, announced that it was selected to receive $3.5 million to supply infrared optics for the F-35 combat aircraft program. Rubin, in our conversation, discusses the capabilities that a germanium-free optic offers an end user and how a legacy material may not always fit the bill. Our conversation with Sam Rubin is coming up today on All Things Photonics. But first, I speak with Lieven Penninck, co-founder of design and simulation software company PlanOpSim. The company's solution is a streamlined, single workflow design software for planar and meta optics, and Penninck offers insights on the impetuses and requirements from industry and from research for such an offering. The story here is that meta optical technologies are continuously expanding, and many more nascent application areas are requiring optical designers move into uncharted territory. How a software design solution addresses that reality means fostering and understanding new applications and their underlying factors. And, with his unique qualifications to answer such a question, we ask Penninck to shed light on something that may be overlooked in metasurfaces technology. All Things Photonics rolls ahead into November with Lieven Penninck from PlanOpSim, followed by Sam Rubin from LightPath Technologies. Both are up next. So I want to begin by talking about PlanOpSim, but I want to take sort of an indirect route to get there, and I want to ask a couple questions first, and ultimately have you describe the company through those answers. But just given what the company does, I want to ask this first. If you're enabling planar optic designers and meta optic designers to optimize their designs, obviously you must have arrived as a business at a point where it was clear that this was a technology that needed a solution on the software side to take it to the next level. And just sort of in the technology arc of metasurfaces, when was that clear to you that this software solution was necessary?
I think the first time it became clear to me was now around 6 years ago in 2018. At that time, I was involved in a very different technical field in organic LED displays and solar cells. And you were starting to see a lot of buzz about metasurfaces, and I met people at conferences and they were doing metasurface research, but it was all very patchy. So I ended up straight up asking them, but like, isn't there some easy, streamlined way to do this? And they said, well, no. And that sort of got the cogs moving inside my head, because in my background as an optical researcher, I knew the different parts that had to be combined in order to make this work. So that was a trigger for me at first to start working on this and start making this software. And that ultimately led to founding the company and starting a business.
In every technology, every worthwhile technology, I should say, be it displays, organic materials, or metasurfaces, there's obviously some buzz, and then the buzz transitions to a reality where there's commercial success. You obviously perceived the buzz and heard about the buzz, and that was an impetus to start the company. Was there then a next level point where you realized, wow, this is really a technology that's taking off and changing the way that we do optics?
It didn't come as like a one sort of lightning flash moment. What we noticed more is how the type of conversations we were having with researchers, with customers, with R&D people was changing. Like the first number of questions, at first the questions were really like, can we do this at all? What can it be used for? And gradually we started getting past that change. Of course, some people were earlier with this than others, but nowadays we see a lot more questions coming about manufacturability, about cost points at high volume manufacturing, about lifetime, about damage thresholds. These sort of questions that show that it's no longer an academic research project. People are seriously considering getting them into mass market applications and are getting more and more into the engineering aspects. And this is a great sign of maturity. So this sort of, for us, also showed that we're now in a different stage where we're no longer in the technology hype part, but really moving to fixing out all the bugs, all the little diseases that you have with every new technology until it's really to a point where it can be applied at mass scale. So we're really maturing now with this technology, and I find that very exciting.
As the technology has matured, and I do promise we'll get into what PlanOpSim software is doing, I just have one more sort of table setting question. This transition, obviously there's a natural transition from R&D and research to industry. Was that apparent at any point where you started noticing that customers were not just experimental, that they were really commercial?
It happened gradually. Like some customers, especially, were very early with tackling these questions, and I think that's very wise, because ultimately these are a lot of the big showstoppers that can happen to a new technology in this valley of that kind of phase. Are those kind of questions about industrialization, robustness, cost points, and so on. So they were right to start tackling that early on, but there was no, I'm sorry, I forgot a little bit what the question was precisely.
Yeah, just asking about if you noticed or perceived a shift from customers and their questions coming from the research side to more coming from the commercial side.
Yeah, we've seen that as well. So early on, it was all research, and research doesn't stop. We still see a lot of research customers as well. But what started happening was the larger companies got a lot more interested, got a lot more serious in the type of questions they were asking.
And now I'll ask.
That's what's going on. And I still think there's a lot of potential, so I don't expect research to stop. This sort of draws back also on my experience in liquid crystals and organic LEDs. As long as there's a good application and a big market, there will be no end to the R&D. They will keep refining those solutions, because that's what you need to do, especially in consumer electronics. New products need to be released all the time.
I want to ask now, I guess, the $1 million question for the purposes of this interview, and feel free to divulge as many secrets as you'd like, but what is it that PlanOpSim's solution is delivering?
Essentially, what we do with our software is we speed up the R&D cycle. In optical design, and especially when it comes to these sub-wavelength nanostructures, the calculations and the design, and anyone that's worked with any of these softwares knows that it's painstakingly slow. You have to do a very detailed solution, and you can only do very small areas. And that just the cycles of calculation take weeks to months to get to a design, individual calculations. It's very common to see people running things for days or several hours. So that just slows people down. And our core realization, this is not just about speed of computing, it's about applying the right method. So what we try to do in everything we do in our software is to make that design cycle shorter. So that means faster calculations, taking the right approximations, but it also means streamlining the connection between design and manufacturing, for instance, by outputting these files, doing these analysis that the manufacturing will need that maybe the designer is not concerned with in the first instance. Taking all of these shortcuts, because in the end, computer time's one thing, but the real costly aspect is a slowdown in time to market. That's why you need these fast R&D cycles. And say the naked hourly cost of qualified engineers, because these are always very highly skilled people that you need to do these jobs. So you don't find them on every corner of the street.
I think it's fair to say, and this is not the case with every company in the optics and photonics space, but this is a unique company, right? When you talk about metasurface simulation software, there aren't boundless companies doing this. It's a bona fide, I think fair to say, new type of company. That said, were there any, you think about other companies in the design software space, were there any lessons borrowed or any lessons applied from existing software solutions and then taking those and applying them to metasurface design and simulation?
Obviously, I drew a lot on my experience in the display and solar cell simulation industry. So there I learned a lot. It basically transformed me from being a scientist and a researcher into understanding how an R&D company and an R&D software is supposed to work. What's really about that? How does it interact with users? From a business side, of course, how's the company organized? How should you communicate? How should you sell this type of software? That's something I learned very much in those years. And what struck me still the most is a lot of software solutions are still very general. Like you can see that a lot of these things are like trying to solve everything. And that's great, of course, if you can solve everything, but it naturally also means that you have a somewhat generic solution. What we try to do very differently in PlanOpSim is to really be specific on our technology of metasurfaces, because running calculations is fine, but without the physical understanding of what you're doing, that's where the real expertise is, and we try to get as much of that as well into the hands of the customers, because I like to tell the people that we shouldn't offer a software, we should offer expertise. And that's all condensed into the software. That's our philosophy here.
We will talk about LEDs, displays, liquid crystal technology in a few moments, because I think that is actually quite relevant to what PlanOpSim is doing and what you are doing. But I want to talk, for the purposes of this question, about meta-optical technology, planar optics technology. It's still widely considered a relatively nascent technology area, and that means the applications are new. There are new applications, evolving applications. What type of applications is PlanOpSim seeing now, and have those evolved from when the company really launched in earnest?
Yeah, they've changed a lot over the years. In the research phase, I would say in the hype phase, people always thought, we will be able to do everything. We will replace all imaging systems with a single lens. It was soon, of course, becomes obvious that there is no magic. There's no single lens that will replace a full 5-10 lens imaging systems, except in very rare cases, maybe. So those sort of pie in the sky questions has gone away, and we've really discovered what this technology is good for. And that's what we see now in the first commercial applications as well. We see a lot of sensing, because the technology is naturally very good in shaping the wavefront for a limited spectrum. So it's a natural fit with sensing all types of specialty beams. And we see also that the market, the customers, are more and more realizing that. We see fewer and fewer people thinking that they're gonna cram a whole imaging camera into a single lens, which we might have encountered 3-4 years ago.
I think this is in some ways an obvious question, but bear with me. I just want to sort of explore the relationship between new and emergent applications and then the solution on the software side or the expertise that you're providing. Can you explain that relationship a little bit? Because again, in some ways it's obvious, but also these are new applications. So we're going into territory that is somewhat uncharted.
So is your question about the relation between expertise and software?
No, it's more about so you encounter a new application or someone comes to you with a problem and they're not quite how to solve it because there isn't a template for it necessarily. How is that addressed on the software side?
Yeah, actually, we do that a lot with our team because usually people come to us with a specific problem, like, hey, I'm trying to make this. My first instinct as an engineer is always, I want to solve this. I want to figure out a way how to do this. And we sort of have to tell ourselves at some point, well, we shouldn't do the customer's job for them. But what we do essentially at that point is we take people through their ideas and how they could tackle that design, how they could start doing that. Like, we usually will point them also to like some of the literature cases or examples or similar technologies, like, hey, yeah, I think this can be done for this and this reason. Or in some cases it's also, well, and I'm sure imaging designers or illumination designers will be familiar with this. Some customer comes with something that violates laws of physics, and then our job's actually to say, well, try what you like, you're not going to be able to do this.
Yeah. Fair enough. And I do want to get back to your experience in displays and display materials. Just a couple questions about that. One, when you're working with OLEDs or liquid crystal displays, that has a much more established technology arc, right? The application is much more established. Then you go into something like meta lenses or meta surfaces, and especially on the design side, that's much newer. Did your experience working in a more established technology era benefit you as you made this transition in your career?
I'm not sure I agree if it's all that established. People always expect technology to move very fast. But the reality also for flat panel displays like liquid crystals or solar cells is that between like let's say the R&D technical emergence of an application and a widespread adaptation, there's often 2-3 decades. So in my time in OLED, I saw that transition happening when I was still part of it. People were still wondering, well, will it ever be in a real product? It was only after several years, I think they had been doing OLED displays for at least 10, 15 years until Samsung put the first OLED into a smartphone. So, and in that respect, the development of meta surfaces has actually been much faster than I expected. Of course, you can argue when exactly was the first meta surface made and what qualifies as a meta surface and what not, but that's all, let's say, semantic discussion. It doesn't really matter. But between, let's say, the first hype and now products entering the market has been relatively short.
Liquid crystals are interesting because I think most people, I would say 4 out of 5, maybe even 9 out of 10, when they hear LCs, they're inclined to add a D, right? They think liquid crystal displays. Yeah. Suppose there are folks who think about spatial light modulation too, but liquid crystals themselves, just as a material, a lot of potential in things like sensing, and not just thermal sensing either, pretty established capabilities. I mean, do you see any parallels between something like liquid crystals and meta surfaces where the sort of the application window is always open, just continuously expanding?
Yeah, I think it's definitely this is like a toolbox, right? In the case of a liquid crystal, you have the ability to change the optical system with voltage. This is a very crude description, of course. There's all kinds of engineering that you actually need to do. And with meta surfaces, it's very similar. You have this toolbox of through the nanostructure manipulating the light. And that's a very wide open space. You can apply this in a lot of directions. And that sort of gives as they say in French, l'embarras du choix, the agony of choice, that there's infinite possibilities. That puts the burden on the designer then, but well, what do I actually want to do? I used to not have control, now I have control, and now I need to figure out what will that control bring me in a real world application. And that's what makes me convinced also that we're still in the infancy of what's possible with a meta surface. We see a lot of people like trying to replace existing solutions with a smaller version of it. Like you make a lens, it's a big block of glass. You take that functionality and you make it into a meta surface, and now it's a tiny piece. And that's good, that's great progress. What I think people have not really started tackling yet is, well, let's walk away from curved surfaces. What other crazy things can we do now that we have full control with it? And there's some work on this, but I would say that this type of applications, the community, the field as a whole, has not really tackled this yet or exploited this potential completely.
Is that something that you see coming? Obviously, this is sort of a very high-level bit of conversation we're having. I suppose the bigger, more specific conversation is, where are we going in metasurface technology? What's the forecast as you see it?
I think we're on the brink of large-scale applications. We're starting to see industrialization. We're starting to see first applications. And these first applications will always be, let's say, what for someone in the field is maybe less exciting, what was new 5 years ago, but has now matured and is ready for prime time, let's say. These other things that I mentioned about radically new types of systems, those will naturally always come later. But I fully expect to see them. What I also expect in the coming years, actually, is that it will become a lot more accessible. If we look at the first sort of ideas when people talked about, yes, we do photolithography in a foundry with CMOS, and that's all fantastic technology, truly remarkable. But the one big problem is this really only works for high volumes. You have a big upfront cost before you can get to these low unit costs. And there's a whole lot of applications where that is a big problem, that you cannot live with these high upfront costs. I think methods will come up in the coming years and will get more popularized, and we are also looking at that, and we have released some things in our software as well, where basically ways to reduce that cost. We've seen this evolution in electronics, we've seen that in photonic integrated circuits, and I'm very sure it will come as well for meta surfaces and flat optics.
I think the challenges with metasurfaces, and do correct me if I'm mistaken here, but I think some of the challenges have existed for a little while. There's a lot of, you hear things like, oh, if we could have a master lens, that would be very helpful, or manufacturability, that's still a bottleneck. Have the challenges with metasurface technology remained? Have they evolved as the applications have evolved, sort of somewhere in the middle?
It's a continuous evolution there, I would say. The concerns that are there, of course, they have been there for a long time, but we see them get gradually less and less as well. We sort of have to distinguish between what's, for instance, the fabrication capability at a small university lab, which can make a nice prototype, and you know how this goes with prototypes. You make 5 and one of them works, and then you have a nice prototype. Whereas then let's say the industrial manufacturers who care a lot more about robustness and quality. And it's in those places that we see these kinks are getting ironed out.
There's also, sort of a parallel consideration is the ecosystem of the technology, right? There are a number of companies in and around the technology space, and I suppose the elephant in the room, if we want to use that phrase, is the NILT acquisition, which is huge news, both in terms of technology, but also just in terms of corporate interest. In terms of the ecosystem, how are you seeing that evolve? And do you have any predictions for where we might be going in that regard?
That's the $1 million. Well, it's more than $1 million question.
$1 million
it's
question.
At least a $250 million question. On the whole, I think this is good for the field because it shows that there is significant interest from foundries outside of the field. If you're a meta surface nerd like I am, then of course you like everything about this. But this shows that the people who just have a pure technical application interest are taking this field very seriously and really getting into it. So on the whole, this is good news. And I expect probably we'll see more of this in the future. We might see some consolidation happening. We might see some new challengers popping up, but all of that, those are signs of a healthy market, I would say. So on the whole, I welcome it.
And I think for PlanOpSim, its own story involves a stint as in accelerator startups, both here in the U.S. and also in Europe. Talk about how that experience or how those experiences have influenced the company and helped bring it to its current state. I mean, is there a real benefit there?
Yeah, I 100% recommend this. So we did two accelerators. One was the IMAC iStart accelerator here in Belgium, and the other one was the Luminate accelerator specifically on optics and photonics. And this has helped us immensely in our journey in becoming mature in terms of process, in terms of how we operate as a company. It's not just about technology, right? You need everything in place to keep the lights on in the company, and especially getting access and introductions to the people that really know our industry has been a tremendous help for us as a company. So especially the Luminate program, there's a lot of, let's say, business accelerators out there which will give you generic advice, but every field's different, and optics is a kind of a special child, I guess we can say. Is that to know how it works in optics, you need to talk to the people that know about optics. And this accelerator has really delivered that for us, brought us into touch with a lot of companies in the field, with a lot of other startups in our field, which has really been of great value, but also just personally of great fun to meet a lot of founders in our industry.
And I think that speaks to the reality that no one company operates in a vacuum, even in the optics and photonics space. So I want to ask you sort of an out there question, but I think it's a relevant one. How does PlanOpSim see the evolution and the takeoff of AI? Because obviously there are some considerations there. There have to be.
Yeah, this is it's sort of always not an elephant in the room, but it's sort of always hanging around there, right, with AI. My personal feeling is that we have to be very specific in selecting those cases where AI really delivers value to the end application, to the end customer. You will encounter things where you just feel like this is AI for the sake of AI, and we should try and steer clear of that. And there are several very high value cases, I think, where AI can be applied, and which specific sub flavor and things like that, that's not really relevant. But we as an industry really have to focus on that. Where does the value lie? What can we really improve tremendously through applying these techniques? And in the end, you can almost see it as a tool, like we did optimization, and then people started calling optimization machine learning. And we have all these tools, of course, in software as well as in other fields available. But the true question remains, like, how can we use this to deliver value? I think that's the end of it.
I've asked this question, I guess, a couple different ways, and we talked about maybe the possibility of consolidation. That's strictly an industry type of question. Perhaps a killer application. That's obviously more on the technical side. But is there anything overlooked or that you feel isn't discussed enough with regards to metasurface technology? Because again, this is a new technology, and even people familiar with it are apt to be surprised by something in the field.
That is a very good question. I don't have a ready-made answer for this one. So if I had the super killer application, of course, I would be starting a different business. And this is a frustrating thing for us sometimes, because we sort of sit in the middle of a lot of interesting design questions. And we sometimes have to say, well, this is a great idea, but we'll have to pass because it's not our torch to carry.
Well, let me ask you this. You're working with a lot of customers, and often very directly, right? You're having close conversations about very specific questions, very specific potential applications.
Mm-hmm.
I mean, is there any time or any instance where you feel like, there's actually some untapped potential here? There are capabilities that if we just, peel back one more layer, we're on the brink of something that we haven't looked at yet.
There's a lot here that I'm not allowed to say, as you will understand. So I'm not going to go into specific applications or anything. It gets back to this earlier question of, like, we have all this design freedom now. What can we really, which direction can we go that was just not possible before? Because a lot of optics design, if you look at everything, if you just open up like a ray tracer, all of it's about spherical lenses, because that's how optics worked for hundreds of years. So the question there is, what becomes possible when we step away from that, when we start to make these wild profiles? And I think there's a lot there possible, for instance, in now having control over the angle, having certain degrees of tunability. I think we will see in the future coming a lot more of that coming.
We'll have to leave it up to our the imagination of our listeners here. I think they can
Yeah.
use their minds to fill in the blanks. Lieven, I want to thank you very much for taking the time to speak with us here on the All Things Photonics podcast. Best of luck, and we'll be in touch moving forward.
Thank you so much. It's been a pleasure.
Today's episode is brought to you by Avantes. Unlock the power of light with Avantes. For over 30 years, we've delivered precision fiber optic spectroscopy, trusted for custom integration and reliable data. Discover how to empower your application, industrial, scientific, or beyond. Visit Avantes.com and experience spectroscopy solutions that innovate. Today's episode is also brought to you by LightPath Technologies. From concept through prototyping, volume production, and global distribution, LightPath has the optical knowledge and manufacturing expertise to be your optics partner every step of the way. Visit lightpath.com to learn more.
And up next, I speak with LightPath Technologies CEO Sam Rubin. Let's start this question and answer session here. About 15 minutes in the past, it's been about 15 months since the industry arrived at what I think is fair to call an inflection point, right around this notion of export controls. And we're talking about germanium and germanium optics here. But this was restrictions around Chinese-produced gallium and germanium, right, focusing on rare earths. And just a reminder, 2023 Chinese directives mandated that its domestic exporters of these rare earths had to obtain a license to move these rare earths out of China. And for a company such as your own, that's highly relevant. I want to ask, how did our arrival at this inflection point drive LightPath to its current point and its current focus on the commercial side?
Yeah, definitely. So I think, we've been preparing for this for a while. So germanium and gallium are both critical minerals that are, a key in optics. They actually probably get used in optics more than they do in semiconductor, even though semiconductor gets more attention in the media. But need-wise, optics is a much bigger consumer of those materials. We've been preparing for this with our colleagues or our partners in Department of Defense for quite a while. I mean, I think we can go back 3 years ago when we licensed from NRL their portfolio of chalcogenide glasses, of new materials that can help substitute for the use of germanium and some of the gallium in optics. And all the way through partnerships with defense logistics agencies, strategic materials, these are the guys that literally sit on a stockpile of germanium, right? They get money from Congress to go and stockpile germanium for a rainy day. And so they understood that rainy day is going to come, and they understood we have an alternative to that. And so we've been working with them on the commercialization and qualification of those materials. So it didn't take us by surprise. If anything, it accelerated some adoptions and some customers that were sitting on the fence instead of saying, well, I know I should do this, but I'm still getting germanium, so it's not a big deal, right? So that has sort of sped up a bit.
So theoretically, right, the big change would be in terms of orders, right? Suddenly there would be an order ramp up. That's a theoretical. Have the conversations with customers, with partners changed in the last 15 months? Just as we've sort of, not near to reality, but really arrived towards one.
Yeah, so the key part to remember, right, for us as technical people is none of those materials are one-to-one replacement.
That's
so
right.
You don't take out a germanium lens, put in a BDNL lens or a black diamond lens, and that's it. You actually have to redesign the system. Once you start redesigning and doing that, you can take advantage of the advantages the chalcogenides have. I mean, germanium is what nature gave you. So it's refractive index, it's thermo-optic coefficient, it's the NDT, it's CTE, dispersion, all of those are given. The chalcogenides are synthetic in a way, right? They're made in the lab, a little bit of that, a little bit of this, mixed together, and you can fine-tune its parameters. So you end up with a portfolio of materials that actually outperform germanium in many, many aspects. So once you start redesigning, that actually opens up the whole option of decreasing the size of the system, improving its performance, its throughput. So it changed things in a sense of the dialogues now are far more technical, are far more around redesigning systems, around, what can be done with these materials. And so it's not orders that came in the next day, because again, it's not one-to-one replacement. But what happened is the next day, those that were only thinking about redesigning or thinking about starting to use chalcogenides dove into it headfirst and started the process, which can be sometimes up to 2 years to redesign a system, to get everything working, designed, qualified, tested, before you even see a production order.
Sure. And I think it's worth going back a little bit here and just to introduce BD, the BD suite of materials, right? This is not this new to emerge magic material, although its capabilities may be close to magic. Just for our listeners, give them an introduction to BD, right? And LightPath isn't the only company working in this area.
Not at all, yeah. Yeah, what we call black diamond or chalcogenide glasses. I mean, it's just easier to pronounce black diamonds and chalcogenides. But these are glass made from family of chalcogenide materials, arsenic, selenium, sulfides, and so on. They're made, as opposed to an ingot that is grown as a crystal, these are made as a glass balls. They're melted in furnaces, go through different processes of melt, annealing, and so on. With that in mind, because they are a mixture of multiple materials, small changes to the composition can result in some changes to the optical or mechanical parameters of those. And so there are a couple of materials that are widely used and has been around for a long time. So that's our BD6, what Schott calls IRG26, that was called IG6. They're all pretty much the same composition. And that's widely used and already accepted. But that alone is not enough to go and displace a material like germanium. And so NRL have developed over the years a portfolio of materials that have unique capabilities, unique technical parameters to them. Some of them are multispectral, in a sense they work all the way from 580 nanometers to 18 microns. Some of them have unique specific parameters, like BDNL8 has a DNDT close to 0. The index simply does not change when temperature changes. Some have DNDT that is negative. Some have a coefficient of thermal expansion that is identical to aluminum. So it allows you to do mechanical design, some benefits there. And so we've licensed that portfolio, and we've been in the last 2 years in the process of commercializing it and getting to a MRL level, a material readiness level, manufacturing readiness level 9. And that is, in order to really accelerate what sometimes could take years upon years of the market accepting and adopting a new material. And we don't have those years and years. We have a shortage now of materials.
One of the things that has to happen, right, and it's not something that happens particularly often, is commercializing something that is legitimately new, a bona fide new solution or product solution. And when you're doing that, one of the things that has to take place is this iterative thing in its qualification. Can you walk us through what qualification looks like for a material? Because different entities have different needs and they all have to be qualified. So it can be a multifaceted endeavor.
Absolutely. So we're very lucky to have found a very strong partner in Defense Logistics Agency that, together with key people in the industry, subject matter experts of the Army on the optics, key optical designers from the primes like Raytheon and such, as well as many SMEs, have worked with us very, very carefully and very closely to define a protocol of adoption and of qualification of those materials. Essentially, you go to an optical designer and he can say, well, germanium has been around for, 60 years. Everyone knows how it behaves. It's easy to design with it. It's predictable. And new materials are not. That is true, but, you don't want to wait 60 years. And so DLA designed this protocol with us in which we run hundreds and hundreds of measurements and samples to demonstrate repeatability and consistency of manufacturing. It's all the way from the obvious, which are refractive index, thermal optic coefficient, CTE, transmission, all the way through things that actually don't usually get measured by everyone, and that is index uniformity across a clear aperture, radiation resistance in space. European Space Agency actually has qualified our materials in terms of radiation resistance for use in space. Developing coatings. Anyone that worked in chalcogenide, is probably now cursing because coatings are, not that straightforward when it comes to chalcogenides. Every materials that we qualify, we have already coatings developed. DLC coatings, diamond-like carbon, AR coatings, different coatings, protective coatings. The idea is to accelerate significantly what would typically be a linear adoption that might take, say, 10 years, in which the market will slowly develop all of those things, get comfortable with the materials, develop the familiarity with them, accelerate that through an investment of millions of dollars that the government has done in this to get us everything we need to accelerate that qualification. This includes a state-of-the-art refractometer that we have now, that we can measure samples directly here in-house. We don't have to send them out. It includes setups for measuring DNDT below 10 ppm. It's a number that wasn't even thought of before, because you think of germanium and those materials, their DNDT is in the hundreds of ppms per degree Celsius. We have a material that's below 10 ppm now. It's below what the machine can measure. You reach the point where you already now need to think of the measurement devices and technology of metrology to qualify those materials. It's actually been pretty fun, to be honest.
Right. And on the other side, sort of this value chain, right, are the customers, and we're talking here a lot about who I would qualify as tier one contractors, right? And earlier this fall, I suppose, last fall now, as we move into no, we're in fall. Sorry, I lost my seasons there for a moment. In any case, a few weeks ago, LightPath was announced that it was going to receive $3.5 million to supply IR optics for the F-35 combat program, right? And that's certainly a tier one. From the optics side, and in terms of performance, and this is a loaded question, I know that, but who better to ask it to? What are we talking about in terms of performance advantages to the BD6 material?
Yeah, so BD6 is one of the materials.
Right. Germanium-free, I should say.
Family, right? I think it all goes back to the ability to fine-tune parameters of the materials. So when we go and design now in optics, we have invisible, let's say. You have a glass map of hundreds of types of glass, right? I mean, that famous glass map of the dispersion and such. You have hundreds of dots on the maps that you can choose from. You can design a incredibly compact and optimal system. In fact, look at the cameras in our cell phones. I mean, the optical performance they achieve is unbelievable. And it's due to the availability of many different materials that work together to compensate each other for different things. When you look at the infrared world, until now, you're looking at a handful of materials, less than 10 materials. And so infrared systems are always bigger, clumsier. You need active elements to compensate for temperature changes, refocus them, and so on. Now you bring in new materials that have unique coefficients, unique parameters to them. Dispersion curves that are different, thermal optic coefficient of thermal expansion, transmission, different wavelengths. And suddenly you have much more variables to sort of play with, if you would. So for an optical designer, going from needing to design a system using only 5 different materials to suddenly be able to design with 15 different materials, that's a very significant change.
Right.
And it shows the systems are getting smaller. Systems have less lens count, so better throughput, and many other great things.
I want to stay on this conversational theme here, right? And in the U.S., I can speak to the U.S. With the greatest ease. U.S. Department of Defense has made significant investment into its high power energy systems, high power laser systems, particularly on the R&D side, but also in terms of rollout. And that begs, I think, a logical question in terms of the optics that are used to enable these systems. And beam control is one thing, but stepping away from beam control optics exclusively, can you characterize where we are, at least in the US, in terms of advancing optics for the DE space in particular?
Yeah, I think, when it comes to the directed energy, and I'm familiar with that through some of the work we've done on using chalcogenides in that. When it comes to that, a lot of this relates to the fabrication, right? The surface quality, the polishing, the subsurface cracks, all of those things. There's some great work that was done in Lawrence Livermore Labs. But unfortunately, because of the globalization or world becoming flat over the years and so on, we have lost a lot of those capabilities in the US. It became very easy for us to just rely on low-cost manufacturing countries for a lot of the capabilities that once, I believe, used to be very core to the US in terms of fabrication capabilities. There's some developments that were done, right? MRF by, QED company is a great one, right? There's some CNC and diamond turning capabilities that were developed, but we definitely need to, and we are, the entire industry, reminding ourselves and going back to polishing and grinding and making optics. And you see that through the programs Americom is putting together in terms of training technicians, So now we have a bit more of a formalized way to train technicians instead of the old German master opticians with apprentices everywhere, many, many years ago.
And that's a good point, though. That was the model, and now there is a vastly different, and I think something that aims to streamline our ability to make improvements.
And we need to, in all honesty, we need to catch up on some things that got neglected over the years here in terms of the most basics of polishing lenses. And, they're doing some great, great strides in that direction here.
I think one of the things that is most interesting about LightPath is sort of the diversification of the company, right? And there have been some advantages, or rather advances, on the product side in particular that speak to this wider range of products than maybe a company that's working in non-germanium optics you would think. And on the product side, targeted advancements in terms of the ability to incorporate AI capabilities into market-ready systems. And the benefits to AI are fairly well known, or at least well imagined. But looking through a defense-first lens, where does LightPath see the opportunity to harness some of what AI can bring?
Yeah, that's a great question. So you're absolutely right. We have been doing a shift and moving up the food chain, if you would, into making cameras and subsystems. Every place we do that, we do it in a place where we have some unique advantages we can bring to the table. A multispectral camera that can image from 3 to 12 micron is made possible because of our materials, right? So that's a place where we have an advantage. The AI is another one. We have a partnership with an Israeli company that allows us to easily integrate hardware for AI implementation into the camera. And so with that, you can take now AI modules that someone developed, and God knows there are many, many that are working on that. No one needs us to develop it. Compile it into this Halo device and run it in the video pipeline in the camera. And so instead of streaming back all the data and then having it analyzed in a data center or in a expensive and heavy NVIDIA GPU, you can actually run the AI module now in the camera itself and only, send back alarms or what is needed. So the implications for that, the applications are enormous. I mean, in defense, think about, cameras looking at the border, and hundreds of cameras. We all remember from the movies, these video rooms you go into and a wall full of monitors. Well, no human can really look at all of those at the same time. So an AI that is doing that and only alerts you when something changed or something happened, and then the person gets into the loop, is a very big deal. Drones that need to fly around, look for targets, say, in the military, and everyone is trying to jam them all the time. I mean, electronic warfare has become a very big deal. So Today, you lose contact with the drone, it's done. You have nothing. If the drone can keep at least flying or keep looking for a target and communicate only when absolutely necessary, that creates a great advantage. I mean, there's just so many exciting places where that can be used.
And I think building on that, I just want to, as we end here, ask you, we've talked about where LightPath has been and where it is now. Let's end with something forward-looking. Where's the company going? Tremendous opportunity in terms of material science and on the imaging side. And then we've talked about the defense sector, but a lot of opportunity throughout, I would imagine.
Yeah, absolutely. I mean, in the 4 years I've been here, we've done a tremendous shift, not only in the strategy, but also in alignment of the organization to that. One thing, for example, is even the geographical presence. In the past, the company relied very, very heavily on its manufacturing in China. In fact, almost entirely on that to some degree, some years. Since I came on board, we've been investing in the US and Latvia very heavily. Nearly $16 million that we invested in the operations in the US and in Europe and in Latvia. We're bringing manufacturing back here, if you would. And I'm not saying it as a political slogan, but just as a reality. We're moving away from being a low-cost manufacturer, focusing on the low-cost labor and on that aspect, to a manufacturer that now creates real value. Unique materials, unique cameras, unique value added that allows us to now work with customers on much more than the lens. So where LightPath is going, where LightPath is going to be, in a couple of years, LightPath is going to be very, very Western-centric with a very diverse business all the way from the materials to the optics to optical assemblies to camera systems.
Well, Sam, it is always great to catch up with you. I appreciate the time and the insights as always. Best of luck going forward. It's been a very busy and very fruitful 2024 for LightPath, and more to come as we move here into the final quarter of the year and into 2025.
Super. Thank you very much. Great to speak to you again.
Thank you.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.